In this video, we're going to talk in some more detail about enantiomers and diastereomers. Previously, we explained that enantiomers were a pair of molecules that are non-superimposable mirror images, and most of the examples that we've looked at have been fairly obvious. However, these molecules are also mirror images, even though you can't tell at first glance. This molecule is the enantiomer, but it's flipped over. Essentially what we did is we flipped every single stereocenter to make the enantiomer. In the previous examples I gave about diastereomers, we talked about how diastereomers are stereoisomers that are not enantiomers, and the examples, of course, were cis and trans. However, these molecules here are also diastereomers. Notice that they aren't enantiomers, but they are still stereoisomers. Let's look at some more examples that we previously talked about. We pretty clearly have a pair of enantiomers here because they're mirror images of each other. However, what if I were to draw this molecule upside down? These molecules are the same. So this is an enantiomer of this one over here. How about on the bottom here? This molecule here is an enantiomer of this one. Let's draw that another way. These molecules are the same, and that means this is an enantiomer of this one. So you have to be able to recognize enantiomers even if they're drawn differently. Also, if we look at this molecule here, it's not completely apparent that it's a diastereomer of this one, but this image I've redrawn makes it a little bit clearer because we can see that one stereocenter is the same and one is changed. So these are not mirror images, but they are diastereomers. One way to represent enantiomers, then, is to flip all chiral centers. And that's exactly what you're seeing in this example here. Every single hashed line here is changed to a wedged line down here. So I'm drawing these molecules exactly the same, except I'm flipping the configuration. We could also draw the enantiomer like this. So this is the enantiomer of this molecule here, meaning that it is the same as this down here. Diastereomers, however, have at least one chiral center the same. That means that we will flip one or more of the rest of the chiral centers. So you can see here that we have the same configuration at this carbon, and the other two here have been flipped to wedge lines on the bottom. We could have drawn another diastereomer of this first molecule by holding that one the same, this one the same, and flipping this one. So this is another diastereomer of the first molecule. There are other diastereomers that we could have drawn. We could have held this one the same and flipped this one. We could have also kept this one the same and flipped both. So there are several combinations that we can have that would give us a diastereomer. If you're trying to draw all the stereoisomers of a molecule, you have to keep in mind that a molecule with n asymmetric centers will have a maximum of 2 to the n stereoisomers. For example, a molecule with 2 asymmetric centers would have a maximum of 2 to the 2, or 4 stereoisomers. A molecule with 3 asymmetric centers would have a maximum of 2 to the 3, or 8 stereoisomers. Keep in mind that this is a maximum. The number can be less if there are meso compounds. Here's an example of a molecule that has 1, 2, 3 stereocenters. So that means that there are 8 possible stereoisomers, and they're shown here. We could have all of them be up, all of them be down, or any combination thereof. However, if we were to have a meso compound, then we might have less. One good example is a cis-cyclohexane. It has 2 stereocenters, so we have a maximum of 4 asymmetric centers. However, because it is a meso and has a plane of symmetry right here, if we draw both of those bromines down, that's actually the same. So we actually only have 3 possible stereoisomers for this compound. On an exam, given a compound, you need to be able to draw its enantiomer and all of its diastereomers. When you're doing this, you need to make sure that you watch out for any meso compounds. That wraps up this video. In the next video, we're going to look at physical and chemical properties of different types of stereoisomers.